Okay, welcome back everyone. In this video we're going to take a look at an example of how to solve a problem using Kepler's third law. And this particular problem is number 101, and I think that's on page 256. Now, in this problem we're dealing with a satellite orbiting Venus, and we're looking at what's known as a synchronous satellite. So that just means the same time. So if something is geosynchronous, that means that it orbits the Earth in 24 hours because it takes the same time for the satellite to go around as it takes for the Earth to spin. So that's geosynchronous, and those are very important for applications like GPS satellites, TV, all sorts of things when if you want constant surveillance on a particular country, you might have a geosynchronous orbit so that a satellite can always be above it. And I'm sorry, this is actually on page 254. In any case, we are talking about Venus now, so we want a satellite which is Venus synchronous, and what we're trying to find is the height of such a satellite above the surface of the planet. And so if we have the planet Venus, here's the center, and here's where the satellite would be, really what we've got for this distance, r here, is the radius of the planet plus the height. So it's that height h that we're trying to find. And we're going to use Kepler's third law, namely that a constant, gm over 4 pi squared, is equal to r cubed. In this diagram it's little r over t squared. Now, when we do this for planets going around the sun, we can use the mass of the sun. But because we're talking about Venus, we must use the mass of Venus. Okay? And what we find here is that the time is 1 day on Venus, which is actually 243 Earth days. So 24 hours, each hour has 3,600 seconds. So the period for 1 day on Venus is about 2.10 times 10 to the 7th seconds. And so now we're just going to solve basically Kepler's third law, and we're going to solve it for r because r is defined as the radius of Venus plus the height. So we're going to have r cubed is equal to t squared g m Venus over 4 pi squared, and we can plug some things in here. 2.10 times 10 to the 7th seconds squared. G, universal gravitational constant. I'm not going to put in units for that, but hopefully you know what they are. The mass of Venus is pretty close to the Earth actually. It's about 6 times 10 to the 24th kilograms, remarkably close. And then we have 4 pi squared. So then when you do this and you take the cubed root, if you raise that to the 1/3 power, what you'll get is that the radius is approximately, well actually it's equal to the radius of Venus plus the height. The radius of Venus is about 6.05 times 10 to the 6th meters. And if you plug, I'm not going to do all the math right now, but if you take this guy and you plug it in for r, and you take this and plug it in for the radius of Venus, you will be able to get that height. And that height turns out to be about 1.5 times 10 to the 9th meters. Okay. And so there you have it. Here's a good way of using Kepler's third law.